Welcome back. This is question 2, just to check that you were okay with it. So I'm going to do a full question 2 here. So looking at the information for question 2, it says it's an ideal transformer and it's 40 watts in both of its coils. Okay. We are told that the secondary coil has a voltage of 80 volts and the primary coil is 2 amps. So let's use our NVIP situation. So here's our primary coil. We are told very clearly not to count the number of coils in each of these. It's just a diagram. So N equals, and then we've got VIP. I always find this is the much easier way of doing it than following any formulas. Okay. We are told that we're told later on, we're told the number of windings in each of the coils in B, but I'm just going to put them here now for you. The secondary coil has 100. We do not know this value here. The voltage in the secondary coil is 20 volts, it's 80 volts, I should say. And the primary coil's amperage is 8. So we know that's the information throughout the whole of the question. So let's have a look. What do I need to know, or what other information do I have from the question? We are told, firstly, that that's 40 watts and 40 watts there. This means I can simply fill in the entire, basically all the other values. So 80 times this value here would equal 40 watts. So this value, I'll do it in another colour, this must be half a amp. Also, going to the other side, we know that this value here multiplied by 2 is 40, so that must be 20 volts. So therefore, it is a step up transformer, and that step up is a multiply by 4. So if it's a step up transformer, then the ratio between the primary and the secondary number of loops must be a times by 4. So if it ends up as 100 loops over here, we need 25 windings here. Okay. So that should give you information for A, B, and C. The question that it asks at the end is, what is the purpose of that iron ring? So we haven't discussed this yet, but the purpose of the iron ring is twofold. Well, actually, we'll just start with the first fold. It is for flux linkage. We remember that this is an ideal transformer. The power in the primary has to equal the power in the secondary, because we are assuming in an ideal situation that no energy is lost. Now, there are 2 ways that energy is lost, and it's lost because of heat, because we know that whenever we transfer and transform energy, we can lose energy as heat. And in this case, the other way of losing energy is that the flux from the first coil, this is the magnetic flux, which is basically, here we are, all the magnetic field lines. Some of this field lines do not enter the secondary coil. So this flux over here, this section just here, there is lost. So we wrap it around a soft iron core to try and encourage these field lines to link into the secondary coil. So the whole idea is to encourage, or to make as many as possible of these field lines over here, this flux, to enter the coil. So it's called flux linkage, to link the flux from the primary coil to the secondary coil. Okay? So that's its main objective. The only problem with that, of course, is that we will see later on that doing this will also, because it's an iron core. In fact, it's a soft iron core. These iron cores themselves will have a change of flux. And as a result, they will have EMF induced in them, And that means the iron core itself will have some EMF, and as a result, it will have itself its own current. And these currents will be called eddy currents, and these eddy currents will lose energy in forms of heat. But for the question of C here, what is identify the purpose of the iron ring core? The purpose is to link the flux from the primary to the second so that as much of this energy from the primary goes to the secondary. Okay? I will meet you in the third video of where we do question 5.